Welcome to my fifth ShowMe. This will be one of the most important ones I ever do for pre-algebra or Algebra 1 students. It deals with the slope-intercept form of a linear equation in two variables. This sort of equation is extremely important in the way that students are taught to manipulate scientific variables and how they're taught to work with data. It's also a crucial part of the introduction to how functions are graphed on the coordinate plane. There's so many different extensions of this lesson that go in so many different directions. It's absolutely crucial that a student of elementary mathematics master the content of this ShowMe. Look at it again and again and again. Let it help you with your homework, whatever it takes. You have absolutely got to understand every nuance of this lesson. Let's start by getting a good visual idea of what slope means. Slope is the direction the line points. There are really four possible kinds of lines based on slope. There are lines that increase as they move from left to right. These lines will have a positive slope. There are lines that decrease as you go from left to right. These lines will have a negative slope. There are vertical lines which have no slope at all. And there are horizontal lines which have a slope of 0. These are the four kinds. You must quickly recognize what kind of slope you're dealing with, either by looking at the coordinates of points on a line or by looking at a picture of the line. The picture is the more popular way to look at things, but eventually, of course, everything comes back to the numbers. Four kinds of lines: positive slope, negative slope, no slope at all, which is a vertical line, and the slope will be 0 when you have a horizontal line. Now, it only takes 2 points to make a line. Any 2 points will do. Let's say that we have these 2 points. I have no idea what their coordinates are. It really doesn't matter to the demonstration. This will be the line that goes through the two of them. In order to find the slope, we need to think about slope this way. Slope is the unit rate of change. It's how much one variable changes every time another variable changes by 1 unit. By convention, we've always defined slope to be the change in the dependent variable, or y, compared to the change in the independent variable, which is x. So we're going to have a ratio. That's how we compare two numbers. On top, we're going to have the change in y. On the bottom, we're going to have the change in x. Again, pictures are always a great way to start this sort of thing. This horizontal line represents the change in x. It starts at whatever the x-coordinate of this point is, and ends at whatever the x-coordinate of the second point is. In the same way, this vertical line represents the change in y. It starts at whatever the y-coordinate of the first point is, and ends up at whatever the y-coordinate of the second point is. The change in y, then, is found by calculating the length of this line segment. And the change in x is calculated by finding the length of that line segment. One of the nice things about lines is that once you've found the slope between any 2 points, you found the slope for the entire line. This ratio remains constant across the entire line. When people talk about slope, especially in your classes, they're going to give the change in y a name. They're going to call it the rise. And they're going to call the change in x the run. So this would be the rise, and this would be the run. They do this to employ a kind of figurative language. It's called alliteration. You see, if you give them these names, slope becomes rise over run. And the fact that both words start with the same first consonant sound, R, is what we call alliteration. It makes it easier to remember. Rise over run is one of the ratios that most quickly pops back into the mind of a long-lost algebra student. But how do you calculate these numbers? Well, they're both differences. The rise is going to be the difference between the new y value and the old one. Now, the old one happened first, so by convention we call the old y value y1, and the new y value is then called y2. It works the same way for the x's. The old x value back here is called x1, and the new one is called x2. We use those values to calculate the numbers in the ratio. You take y2 minus y1 to give you the rise, and we take x2 minus x1 to give us the run. That's how we calculate change, the newest value minus the oldest value. Remember that you always have to be able to do these things without looking at a graph too, especially if you intend to use a computer or if you intend to extend these ideas into more advanced ones. We have a standard letter that we always use for slope. We always use m. I have looked and I have asked, and there is no satisfactory explanation for why we use m. But everybody in the math club does, and so you will too. Remember what I showed you on the previous screen. The change in y divided by the change in x. The new value of y minus the old value of y. The new value of x minus the old value of x. These numbers come from 2 points. Any 2 points on the line will do. x1, y1, and the other point is x2, y2. Now those 1s and 2s don't do anything mathematically. They're identifiers. They tell you which point they go with. The x1, y1 point is the old point, and the x2, y2 point is the new point. My convention, and you'll see this in every example that I do for you, the old point is the one that's further to the left, and the new point is the one that is further to the right. I will always follow that convention. For me, we always work from left to right. So if we have a line through these 2 points, I would call -2, -3 my old point. That would make -2 x1 and -3 y1. 4 would be x2 and 5 would be y2. Remember the slope formula, m equals y2 minus y1 over x2 minus x1. I strongly recommend that until you have this very thoroughly memorized, you should repeat writing the formula over and over again until you've got it. So, for y2 we have 5, and for y1 we have -3. For x2 we have 4, and for x1 we have -2. 5 minus -3 is 8. 4 minus -2 is 6. That reduces to 4/3. What that means then is every time the y value goes up by 4/3, the x value goes up by 1. That's the rate of change. 4/3 for y for every 1 unit of change in x. Please leave your slopes as ratios like this. This is very convenient for the work we have to do with lines. Now let's look at a decreasing line. See how its slope looks. Remember the formula, m equals y2 minus y1 over x2 minus x1. Remember that I always work from left to right. So 2 is my x1, and 5 is my y1, 10 is my x2, and -1 is my y2. So I'll have -1 minus 5 over 10 minus 2. -1 minus 5 is -6. 10 minus 2 is 8. That reduces to -3/4. That tells us that the y value will decrease 3/4 of a unit for every 1 unit of progress to the right for the x unit. Again, leave these as ratios, even when they look like they could become mixed numbers. You can go to decimals if you want to, that's appropriate, but mixed numbers really make a mess of this. So please leave them as ratios. If you must, you can go to decimals. Let's take a look at a horizontal line. Again, working from left to right. This will be my x1, this will be my y1, this will be my x2, and this will be my y2. Our formula again is m equals y2 minus y1 over x2 minus x1. y2 is 4, and so is y1. x2 is 7, x1 is negative 4. We have 0 over negative 11, 0 over 11, which is 0. I told you before that the horizontal lines would have a slope of 0. I meant it. Think about what it means. On a horizontal line, the y value goes up nothing at all. Every time the x value goes up 1. That makes perfect sense. If you look at a horizontal line, you realize y never goes up. And so having the slope of 0 makes perfect sense. Now let's take a quick look at a vertical line and see what's going on there. This one's tougher to deal with because there is no left to right for a vertical line. It doesn't change from right to left at all. So I'll just pick one. Let's say that I'll make 6, negative 2 my first point. So x1 is 6 and y1 is negative 2. x2 then is 6 and y2 is 6. Recall our formula, y2 minus y1 over x2 minus x1. So we have 6 minus negative 2 all over 6 minus 6. So you have 8 on top, 0 on the bottom. That's a calculation you can't complete. A lot of people like to say undefined. Well, yes, the answer to that calculation is undefined. But the question that was asked was not, gosh, what does the calculation produce? The answer to the question is, first of all, the question is, what's the slope of the line? The answer is, it doesn't have one. There is no way to complete that calculation. It has no slope. Not at all. And you can see the difficulties coming in the simple fact that you can't even identify where a line like that would begin and end, or where it would be earlier or later in a sequence of points, because it doesn't change from left to right at all. Remember that in science, your most common x variable is going to be time. You're going to see how things change over time. It'll be that way in business too. So without a change in time, there really is no meaning. There should not be two values, none, much less the infinitely many values that there are in a vertical line at one given time point. So in this situation, there is no way to calculate a rate of change, and that's the result you get. There is no slope at all. A y-intercept for a line is simply the point at which the line hits the y-axis. On the y-axis, all of the points have an x-coordinate of 0. Every single one. So, it's not really interesting to talk about the x value at all. Generally, we don't. Here we would say that these three lines, all three of them hitting the y-axis at the same place, they all have a y-intercept of 3. The standard letter we use in America for the y-intercept is B. In Europe, they would use C. It doesn't really matter. All the number is a representation of the y-coordinate where a line strikes the y-axis. It's important, especially in science or business, because it represents a starting point. In a science experiment or in a business graph, time starts at a particular point, often called 0, but it's the beginning of any kind of observation, operation, or data collection process. And it starts at 0 and it only goes to the right. There is no left side of the graph when you're doing a science experiment. Time starts at 0. As a result, this point, the y-intercept, is very important because it's the beginning point for the measurement. It's the initial or pre-observation. It's where something begins. And what happens to it after that is very important. That's why lines like these might be drawn onto a graph, is to analyze the behavior of a dependent variable as the independent variable, in this case time, changes. So what does it all mean? Why do we care about these two topics together? The reason we care about them together is that it just so happens the very, very informative equation sums up both pieces of information very conveniently. If someone told us that a line had a slope of -3 and an intercept of 5, we can very quickly put together an equation that represents the relationship between the independent and dependent variables. The dependent variable is equal to -3 times the independent variable plus 5. It will always work that way. If anyone tells you a slope and an intercept, you should be able to formulate a slope-intercept form equation instantly. In general, slope-intercept form is an equation of the form y equals mx plus b, where m is the slope and b is the y-intercept, the y-coordinate of the point where the line hits the y-axis. Well, let's say that you know that the slope, the rate of change between the two variables, is 5. And you know one of the observation points is -2, 1. Well, that's not the y-intercept, so you can't just jump in and write an equation for that. But we have enough information here to figure out everything else you would need to know. The way you handle this is first you write out the equation in its most general form and make the substitutions that you can make. Well, actually, there are 4 variables in the equation and there are 3 numbers you can put in. Obviously, 5 goes in for m because m is slope. Not so obviously, but very usefully, -2 can go in for x, as long as 1 goes in for y. If 1 isn't going for y, then -2 can't go in for x. They must go in together. But since they're both available to us right now, we can use them to turn this into an equation where only one variable is unknown. That's useful. From here then, 5 times -2 is -10. Add 10 to both sides, and you find out that the y-intercept of this line is 11. Knowing that, we can go back and sum up all the data, all the information about this relationship in one simple, powerful equation. Y equals 5x plus 11. All the information we needed, all of it, is right there. One of the most common and most challenging problems students face in this part of the course on pre-algebra or algebra 1 is trying to generate an equation when you're only given the 2 points. Remember that 2 points always do determine a line, so it should be able to do this, and you can. But it requires some work, and most challengingly for my students, it requires some organization. First of all, always start with this. Now you need to realize something. When we're done, we're not going to know what y and x are because y and x are variables that change. What we need to figure out is what m is and what b is. Once we know m and b, we can write our equation and sum up the relationship tidily in one nice, neat equation. So we need to find the slope. Well, the slope, as we discussed before, is y2 minus y1 over x2 minus x1. Now, 2, -4 is further to the left, so that's where my old numbers are coming from. And 5, 5 will be my new numbers. So my y2 value is 5. My y1 value is -4. My x2 value is 5. And my x1 value is 2. 5 minus -4 is 9. 5 minus 2 is 3. 9 over 3 is 3. The y value goes up 3 units every time the x value goes up 1 unit. My slope is 3. Now I need to find my intercept. Well, now that I have that 3, this is not a hard chore. You see, I can take that 3 along with 5, 5, and put them into the equation. I can put 5 in for y, as long as I put 5 in for x. I can put 3 in for m now that I know what it is, and that leaves me a y-intercept to discover. 3 times 5 is 15. And subtracting 15 from both sides, we discover that the y-intercept is -10. Given those 2 pieces of information, we have all that we need. The answer, the one equation that sums up this entire relationship, is y equals 3x minus 10. Let's sum up the lesson. You should be able to identify what kind of line you're dealing with anytime you have a graph to look at. A line that increases as you move from left to right will have a positive slope. A line that decreases from left to right will have a negative slope. A horizontal line will always have a slope of 0, and a vertical line will have no slope at all. When visualizing slope, we look at the change in the y value and compare it to the change in the x value. We call the change in the y value rise and the change in the x value run. Slope in general is rise over run. And when you have a picture to look at, this is not very hard to construct at all. If you don't have a picture to look at, if you simply have the coordinates of 2 points, you can still do this quite easily because y2 minus y1 has the same meaning as rise. It's a new value of y minus an old one, in other words, the change in y. And on the bottom, x2 minus x1 representing the change in x. y2 minus y1 is a way to sum up rise. x2 minus x1 is a way to sum up run. I always choose to do this from left to right, so my 1 values will always be the leftmost point, and my 2 values will always be my rightmost point. It doesn't really matter, you can do it either way, but that is the way that I will always do it in my examples. The y-intercept is simply the point where a line hits the y-axis. So it's simply the coordinate of this point right here. The x-coordinate is not interesting at all because if a point is on this line at all, x is 0. And we know that for every single point. So there's no information in that number. So we don't ever talk about it. If you talk about a y-intercept, you're talking about the y-coordinate of the point. As always, the most important question about any lesson is, what do we use this for? We use it to discover the equation of a line. The slope-intercept form of a linear equation in 2 variables is y equals mx plus b. It contains 2 extremely valuable pieces of information, the slope and the y-intercept. We can discover that information very quickly using substitution and the algebraic methods we've mastered earlier in the course. We learn to solve for one missing number. You should be able to find the slope-intercept form if someone gives you the slope and the intercept, the slope and any point on the line, or if you are given 2 points on the line. Unless you have that information, any one of those combinations, you should be able to find the equation of the line without even graphing it. I hope this has cleared up some things for you. I hope you find the information useful. This is a crucial lesson. Again, I encourage you, run through this again, repeat this, practice this skill over and over again, because it's a vital part of statistics classes, science classes, business classes, any class where you've got to summarize data, particularly when you have to summarize it by drawing a line.